This lesson is on adding fractions that have mixed numbers. In the previous lesson you had proper fractions that you were adding together, so we always got to skip a step. Here we are going to use all 5 steps, and these problems can take a while to do. They will take a lot of space. Definitely if you want to grab out a separate sheet of paper to work out some of the math that's involved with this, then go ahead, because there's not a lot of room here. I'm going to have to use the whole white space that you see here just to solve one problem, and then have to probably erase my work to do the next problem. So let's look at number 1 and follow our steps. It's the same 5 steps as we had before. If you didn't do so in the previous lesson, go ahead and write these 5 steps somewhere, maybe in the margin or at the top of your paper, wherever you can find room. If you want to write it on a separate sheet of paper or a post-it note and just attach it to this worksheet, I'd advise you do one of those things at least. Alright, let's do our 5 steps. First step, if it's a mixed number, change it to an improper fraction. So let's remind ourselves what we do to change a mixed number. Here we have 6 1/5. It's a mixed number. Let's stir it up, mix it up, and remember you have to multiply and then add and write it over. So 6 times 5 is 30, and you add 1 to that, that equals 31. I'm going to go ahead and write it down right there, over top of the number that you start with, in this case the 5. I'm going to write plus, and then convert the other mixed number into an improper fraction. 6 times 2 is 12, plus 1 is 13. And I write that over the number that you start with, the 2. So that's what we mean by step 1, changing any mixed numbers into improper fractions. Now if only one of those were mixed numbers, then obviously you'd only need to change one of them and just copy down the other fraction. Our next step, just like in the previous lesson, we have to make sure we have common denominators. Our 5 and the 2 are not the same, so we have to crisscross. 5 times 13, and now we're going to start seeing multiplication with quite a bit larger numbers, and even division here later on. Sorry for the barking, just a second. Okay, so we were multiplying 5 times 13. I'm going to do it down here. 5 times 3 is 15, and you have to carry your 1. 5 times 1 is 5, plus 1 is 6, so you get 65. And I'm going to just write that up there. Then 2 times 31. Doubling a number, most people can do in their head. So the double, whenever you're multiplying a number by 2, it's just doubling it. So if we doubled 31, we get 62. And then multiply your 2 denominators together to get 10, and that will be your common denominator. We're ready for step 3, adding our numerators together, so 62 plus 65. We're adding, so that's 727. All over the denominator of 10. Ready for step 4. We have an improper fraction that we need to change to a mixed number. So we'll put our top number in the box, and we're dividing by the denominator, the 10. 10 can go into 12 one time, and it has a remainder of 2. Now we're not done because we have that 7 you need to bring down. 10 goes into 27 2 times. So we get 20, and you have a remainder of 7. Sorry, I'm running out of room there at the bottom. Your final remainder should never be bigger than the number that you're dividing by. So that's how I know that the 12 is a good number to use. So what do you do with your remainder? Remember that that becomes the hat of your fraction, and the denominator is whatever number you divided by. So 10. 12 and 7/10. Our final step says to check to see if you have to reduce. Well, 7 over 10. Let's see if that reduces. And I have a discussion to have with you about this. So just a second. Okay, so 7 and 10. So the number 7 can only be divided by 1. Numbers that can only be divided by 1 are special. They are called prime numbers. Prime. So you're going to save yourself a ton of time by identifying prime numbers. If a number is prime, you only have two choices here. Either the fraction 7 over 10 will not reduce, or the only thing that will reduce it is if that prime number can go evenly into the other number. Now let me show you the factors of 10. We've done this before, 1 and 10, 2 and 5, and that's it. So you see that the only number that goes in, the greatest common factor for both numbers is just 1, and that means that it stays 7/10. But we could have saved ourselves some time with those factors of 10 by recognizing this prime number. If a number is primed, either the numerator or the denominator is primed, it doesn't matter which one, it has to go in evenly into the other number. Well, can 10 be divided by 7? No. So because it can't, then that means that 7/10 would not have reduced, and you wouldn't have to spend your time making up the factor pairs. Let me give you an example where you'd have a prime number and it does go into it and how you get the final answer. Which, by the way, the final answer for number 1 is that 12 and 7/10. That's it. But let me just show you another example of the prime numbers and what you'll get when you're reducing if you have a different type of fraction. Okay, so I wrote down the fraction 5 over 10. This is another example of a prime number. 5 is a prime number. Yeah, this is part of your problem. I just want to show you something here real quick. 5 is a prime number. It means the only number it can goes into it is 1. So if we look at our denominator 10 and ask ourselves, can we divide 10 by the prime number 5? Yes, 2. It goes in evenly 2 times. Then that means if it does go in evenly, your fraction will always reduce to 1 and whatever answer you get, 1 over 2. Just save yourself that time. So 5/10 reduces to 1/2. Do you need another example of that type? Let me think of one for you. What if you had the fraction 7 over 28? Well, this number 7 is a prime number. So either 7 over 28 won't reduce, or if 7 goes into 28 evenly, which 28 divided by 7 is 4, right? Then that means that 7 over 28 reduces to 1 over 4. We saved ourselves some time. Don't believe me? Let's write all the factor pairs of 28 and see how long it takes you to do it. Factor pairs of 28. 28 divided by 1 is 28. 28 divided by 2 is what, 14. 28 divided by 3 is, what is it? 3, does it go into 28? I don't think so. Or is it 6? I always forget that one. 4 and 7. 5 doesn't go into it. 6 doesn't go into it. So that's it. So we spent all that time when all we had to do is divide 28 by 7. Alright, let's see if we can apply that concept to our future problems. Alright, let's look at problem 2. Let's follow the same 5 steps. First step, we need to change our mixed numbers into improper fractions. 3 times 4 is 12, plus 2 more is 14, all over 3. Plus, change our other mixed number. We stir it up, mix it up. 5 times 5 is 25, plus 1 is 26, all over the number you started with, the 5. Our next step is we need to find common denominators, so you have to crisscross. Here we're getting big again. 26 times 3, 18, carry my 1. 3 times 2 is 6, plus 1 is 7, so 78. 5 times 14. 5 times 4 is 20, carry the 2. 5 times 1 is 5, plus 2 is 7, so 70. And 3 times 5 is 15. So I found my common denominators, and I'm ready to add the numerators together. 70 plus 78 is 148 all over our denominator of 15. Here we have a great big improper fraction, so we need to take the top number and put it in the box. I'm going to rework that a little bit higher so I have some room. $148 divided by 15. And here I'm stuck with, oh, how many times does 15 go in 148? I know some of you don't care for long division, myself included, because sometimes it's hard just to guess what number to start off with. So I have to estimate a little bit. 15's kind of close to 20. I know that there's 5 20s in 100, so I know it's greater than 5. And there's at least 2 20s in 40, so maybe 6, 7. Let's try 7. Again, I'm just estimating here, so if you're hollering at me like, hey, I think it's 8 or I think it's 9, then it's okay. I'm just taking an estimate. I'm going to show you what you can do in long division if you find out the number that you chose is not big enough. So 7 times 5, or if it's too big, 7 times 5 is 35. Carry my 3. 7 times 1 is 7, plus 3 more, that's 10. Look at that. I'm going to get a remainder of 43. That is way too big. Remember, your number has to be smaller than the number you're dividing by. Your remainder does. So I'm going to back that up. I don't want to use 7. I need something great big. I saw that I was pretty far off, so I'm going to jump up to 9. 9 times 5 is 45. Carry my 4. 9 times 1 is 9, plus 4 more is what, 13? Oh, this looks a lot better. 8 minus 5 is 3. 4 minus 3 is 1 is 13. 13 is smaller than 15, so that means my 9 is big enough. Alright, so my remainder is 13, so it becomes my hat of my fraction over the 15 that I divided by. I'm now at 9 and 13 over 15, and I need to see if the 13 over 15 can reduce. Let me erase so that I can give myself some room here. $13 over 15, so I'm going to write my factor pairs of 13, and I find out that, oh, the only thing I can divide 13 by is 1. That makes it a prime number. So here we get to use that rule again. It's either going to go into the denominator of 15 or it's not, and therefore it can't reduce. So 15, can we divide it by 13? No. That means that 9 and 13 over 15 is your final answer. While I'm erasing and getting set up for problem number 3, why don't you go ahead and start it. Get as far as you possibly can. Push pause while you're doing it, and then push play when you're ready to see, check your work as I'm doing mine. We'll see how far you get. Maybe you get all the way down to your final answer, which is great. I'm going to do problem number 3 and number 4 with you before you're set to do the rest for your practice. Okay, let's see how far you got. First step, change those mixed numbers into improper fractions. So 3 times 1 is 3, plus 2 more is 5 over the 3, plus 6 times 5 is 30, plus 4 is 34, all over 5. We do not have common denominators, so we have to crisscross. Let's see, 34 times 3 is 12, carry 1. 3 times 3 is 9, plus 1 is 10, so 102. 5 times 5 is 25. And 3 times 5 is 15. I'm ready to add my numerator, so I have to add 25 to 102. So I get 127 all over 15. And then I have an improper fraction, so I put the top in the box. And I have to estimate now, how many times can 15 go into 127? Well, let's see. 15 again is close to 20, and I know there's 5 20s, and this didn't really work for me last time, did it? So I underestimated last time. Let's see if I get close here. 5, 6, I'm going to go with about 7 times. 7 times 5 is 35. Carry my 3. 7 times 1 is 7, plus 3 more is 10. Oop, it's still not high enough to, I get 22. That's too big. But 22 is really not far off from 15. I must just need to bump it up 1. So I'm going to back it up. Instead of dividing by, instead of 7, I'm going to try 8. So I know I'm pretty close. Try dividing by 8 this time. 8 times 5 is 40. Carry my 4. 8 times 1 is 8, 9, 10, 11, 12, 12. Oh, there we go. Remainder of 7. So I put my 7 over top, 15. I need to see if 7/15 can reduce. And the factors of 7 are 1 and 7. That's it. It's a prime number. Well, 7 doesn't go into 15, so that means it can't reduce, and that's my final answer. 8 and 7/15. Alright. Okay, go ahead and push pause and try number 4 as far as you can. Try to get all the way to the end and then push play to check your work. Alright, you ready? This is the last practice problem I'm going to do with you, and then the rest you're going to have to do on your own. First step is I need to change the mixed numbers and change to improper. 10 times 1 is 10, plus 5 is 15, over 10. By the way, if you find that you make a mistake along the way as I'm showing you these, then push pause and try to fix the rest of your problem before I show you the whole thing. Plus 7 times 5 is 35, plus 4 is 39, all over 5. I do not have common denominators, so I need to crisscross. 10 times 39. It's real easy to multiply numbers by 10 because all you have to do is add a 0 to them. So that makes it 390. I just added the 0 to 39. It's a little quick trick about multiplying by 10. 5 times 15. I'm going to do it up here. 15 times 5. 5 times 5 is 25. 5 times 1 is 5, plus 2 more is 7, so 75. Multiply 10 times 5 and get 50. There you go. Again, multiplying by 10. You just add a 0 to it. You need to add your numerators together. So we have 390 plus 75. I keep on doing that. 9 plus 7 is 16. Carry your 1 is 4. So we get 465. Wow. All over 50. That is a very top-heavy fraction that I have to put the top in the box to. So 465 divided by 50. Might be a little bit easier for me to estimate because I know there's 2 50s in 100. So if there's 4 hundreds, that means I need at least 8 50s. And then 65 is even greater than 50, so let's try 9. So 9 50s. Let's see what that is. Well, 9 times 0 is 0. 9 times 5 is 45. Subtract. 5 minus 0 is 5. 6 minus 5 is 1. And 4 minus 4 is 0. So our remainder is 15, which is smaller than what we're dividing by, the 50, so we're good there. We know it's 9. And then we write 15 over 50. So we're done with step 4. And then step 5 is we have to reduce. Alright, I need some room here. So I'm going to erase some spots here so I can try to reduce that. Oops, I erased the 15 by accident. Alright, I need to reduce 15 over 50. Now I know 9 is part of my final answer. I'm going to write that down there, but I'm reducing 15 over 50. So 15 and 50. I'm trying to find the greatest common factor so that I can reduce it. 15 divided by 1 is 15. 15 can't be divided by 2. It can be divided by 3. 15 divided by 3 is 5. And the only number between 3 and 5 is 4. So 4 doesn't go into 15, so that's it. That's all the factor pairs of 15. For 50, 50 divided by 1 is 50. 50 divided by 2 is 25. 50 can't be divided by 3. Can't be divided by 4. It can be divided by 5. And that's 10. Can't be divided by 6, 7, or 8, or 9, so that's it. The greatest common factor then is our 5, and the numbers beside our greatest common factors are 3 and 10. That means the fraction 15 over 50 reduces to 3/10. So your final answer for problem number 4 is 9 and 3/10. How'd you do? Okay, go ahead and take the rest. Do the rest for practice, and you can click on the self-check and correct to see if you have the correct answers on these. Good luck.